Hello everyone, welcome back to the one more session of multimedia systems. In this session, we will be starting with a discussion with a new topic called the data compression. So, what are the contents of this topic? So, the contents of the topic goes like this, that is the storage space, the coding requirements, source entropy and the hybrid coding, and also the basic compression techniques will be discussed. And also with respect to the compression techniques, we go with the JPEG, that is image preparation, in which lossy sequential DCT compression mode and expanded lossy DCT-based mode will also be discussed. And also the one more category, that is a lossless mode, will also be discussed with respect to hierarchical mode, that is H.261 and H.263 will also be discussed. And with respect to the lossless mode, the image preparation, the various coding algorithms, the data streams with respect to MPEG, encoding, audio and other coding streams will also be discussed. And also we discuss about the various fractal compression in this technique. So before starting, let us look into the basic things. So in order to start with the things, we need to know the in and out of the compression, then we can precisely venture into the concepts. So let us know what do we mean by compression. When I talk about the data compression, it is preliminary work for us to know what do you mean by compression. The definition of a compression goes like this. The compression is an action or a state of being squeezed down, means the suppressing, or made into a smaller, or a compressed or a pressed together. It's an action, means squeezing, making it smaller or pressing together is said to be a compression. When a pile of materials is squeezed together and made into a smaller or a more dense material, then that is called a compression. Let us take into a simple illustration. Now look at this A4 sheet. Okay, this is not a compressed one. So we fold it. Look at the size. The size of a A4 has been reduced into half. It's folded, is said to be a compression. The one more method of compression, it says the squeezing down. See, I am squeezing it. Okay, or pressing it more together. See, I am pressing it. So such a big A4 sheet has become a small ball of a paper. So this kind of method is said to be a compression. Then what do you mean by data compression? As the name itself suggests, compressing of data, very simple. The data compression, when we wanted to go with a standard definition, the definition goes like this. The data compression is a process of encoding or reconstructing or otherwise modifying the data in order to reduce the size. That's it. In simple words, so encoding of data, reconstructing it or modifying the data to reduce the size of the file is said to be a compression method. So compressing of data in order to reduce the file size is said to be the data compression. Then why is data compression important? See, when we know all the answers for this kind of question, it would be very interesting or easy for us to understand the concepts of compression. So next is why it is important. So when we know about the data compression, it is reduction in the number of bits needed to represent the data. Means if our bits are more, obviously the size of the file is more. Now what we do, we reduce the size of the file by reducing the representation bits. Means if a file is represented by 16 bits or 20 bits of information, we reduce the representation bits into 8. When we say about a half, obviously the size of the file is reduced. So by this we can get the reduced file size. Compressing the data can save the storage capacity, very important, because the size of the file is been reduced, so storage occupied would be, obviously it would be very less. And secondly, the speed up of file transfer, it is always easy and convenient. We have seen if the file size is very small, the transferring of file is very easy. It might be from one system to another system, or it might be over the network or with the internet, and also decreases the cost of storage hardware and the network bandwidth. Obviously it is very clear, when we have a small size file, it uses the less hardware storage, means we can accommodate more such kind of files, and also network bandwidth would be very much less needed in order to transfer the data over the line. So these are the important things that why the compression is so important. Then what is data compression, and when we see how does it work? When we talk about the data compression, simple, it is a process in which the file size is reduced by re-encoding or encoding activity of a file and into a fewer bits, because you might have been seen or aware of it, a file will be encoded in a particular bit size. So what we do, we encode it, means when we encode it, we reduce the file size, so by representing lesser bits of information. So after compression, what happens, the file size would be reduced to some extent. It might be, if a file size is 10 MB, after compression it would be reduced into 8 bits or sometimes 5 bits or so on, 8 MB or 4 MB or something else. So this process is called compression, and we want to retain or regain back the original component, then we need to uncompress it, and that process is called the decompression, means the compressed thing and the opening or getting back into the original thing is called decompression. Now let us recall this experiment itself, the illustration. Now this is the paper, I squeeze it, it has become a compression, means now the original form has been changed into one more form. Now if I redo the work, or if I want to get back to the things, what I do, I uncompress it, means this process is called decoding. So the process of compressing is called encoding, means all the things has been suppressed, merged or pressurized to make a smaller size. See, the size was a bit A4 size sheet has been encoded into small ball of paper. Now what I do, I decompress it. That process is called decoding. So it was encoded, is been pushed back, and this process is called decoding. It can also be very beautifully represented with the diagram. Look at this. So when we know that the original data is pushed into the encoder, let us consider the data is X. So what we have here, original data. So when the original value is pushed into the encoder, what happens here, it is compressed. How it is compressed? We all will go through that one by one with respect to the next subsequent session. What are the different compression technique, algorithms, and how it is compression happening, everything. Now the original data is pushed into the process called encoder, where it is compressed, and the data would be Y. That is, X is compressed into the data Y. Now the compressed data is called Y. Now when we wanted to get it back, we need to do the process in a reverse order from encoded to original one, that is called as decoder, and that process is called decompression. Now look at this, the data X is compressed into Y, and again if you wanted to get the original data, we would be decoding it. The process called decoder will be there, and the process of decoding is called decompression, and what we get the data would be the X cap. So this is the basic data compression concepts. Very simple. So original data will be there. We compress it through a concept or a process called encoding, where the encoder compresses the data and it would be Y, that is compressed data. Here X is a uncompressed data and Y is said to be a compressed data. Now when we wanted to retrieve this information, we need to decode it. So that process of decoding is called the decoder. It does the process of decompression, means all the compressed data is released back. That data would be X dash. These are the basic components of a compression. Next, why data compression is very important in today's world. Why is it so important? In today's world? Because we see a lot of research and lot of importance is given to the concept called data compression. Let us look into it. So data compression refers to the reducing the amount of space mainly needed to store the piece of data. We know that. So although computer storage is relatively cheap when compared to the previous technology and the years, now the storage space is cheap, but the amount of data is been inversely high, means here the value of the storage devices are getting cheap, but the amount of data that is being used in today's world is directly going up with respect to the exponential way. Means people are using more and more amount of data and trying to store more and more amount of information in the secondary storage devices. So there is huge amount of data utilized in today's world. When people are using the huge amount of data, obviously we need to store the data with reference to the future use, or in order to do some analysis, manipulations, calculations, or these data might be retrieved for the future use. So in order to do all these activities, we need to store this data. So this storing of huge amount of data is an hectic work. So in order to manage or overcome this problem, the ultimate solution is the data compression. So this is why in today's world the data compression is getting more and more popular. Then what is needed for compression? When we talk about compression, what is it needed? The purpose of compression is to make the file, or it might be a message, or any other chunk of data smaller. That's it. So the main intention that the compression is needed is to make the file, or it might be a data file or any other multimedia file. When you talk about multimedia, it might be an image, a video, audio, or anything. Data might be there, text also. So compression of file, it might be a message or any kind of data to a smaller representation and storage space is the main need for the compression. And data compression can significantly decrease the amount of storage space with respect to the file that has been used. Now we know about the basic things, that is what is compression, what is data compression, why is it so important, and how does it work. We have represented with the help of a diagram, and also we have discussed why it is so important in today's world and what is the main need for compression. Let us discuss with respect to the next concept, that is the types. Let us start with the different types of compressions. Compressions are mainly or broadly classified into two types. What are those? The first one is lossy and second one is lossless compression. As the name itself suggests, lossy means where some amount of data might be lost, whereas lossless is the compression where the data is not at all lost. Let us represent it with the help of a diagram. This is data compression methods. So, data compression methods are broadly classified into two. First one is lossy method, second one is lossless method. So, what are the things that come under lossy methods are? It might be image, video, data, and also to some extent audio. Whereas in the lossless method, mainly it comes under two things. What are those? Text or the programs. Now these are the two categories. Let us go with the lossy and lossless method. So when you talk about a lossy compression, what happens in the lossy compression? Lossy compression restores the large file into original form with loss of some data which are considerably very much negligible. Okay. So why do we need to restore? We need to restore the image or we restore the data after compression. That is called a decompression method. During that process, in the lossy method, there might be loss of some amount of data which can be considered very much negligible, and that, but even though it is negligible, there is some loss of data or loss of information. That kind of method is said to be the lossy method of compression. What are the things that come under this category is the image, the video and the audio comes under lossy compression. Means if you try to compress any one of these, there might be a possibility of compression. After compression is done, when you try to decompress the data, the quality of the information might be lost to some extent, which is very much negligible. But when we try to look into the quality or a data quality in depth, we are able to distinguish there is a loss of information with respect to the original and the compressed data. So this concept is called the lossy method. When we look into the lossless method, while the lossless compression restores the large files to its original form without any loss of data. Means here after compression, when we try to restore the information with respect to the decompression or decoder mode, the file is recalled or returned back or recovered back without any loss of information. Where do we achieve this? We mainly achieve with respect to the text or some of the programs. These are the two main categories with respect to data compression. First is a lossy, second one is lossless compression. Then there is one more question most of them ask, can compression corrupt a file? One of the students asked me question, sir, why do we need to compress this? I said to lessen the storage things. So the size of the file so that it would becomes convenient to store, retrieve, transmit the data. And one of the students said, sir, I have heard that the compression would corrupt the file. So is it so? It is not so. There is nothing about the compression that increases the likelihood of corruption. We cannot say that the compression would cause a loss of information or corrupt the file itself. There is nothing as such, only it might reduce the quality, that's it. The original quality or the quality of the data might be lost to some extent, but file would never be corrupted. If a file is about to get corrupted, and what is the use of using the compression technique? So compression technique, the intention is to just reduce the storage space or reduce the storage size of the file, that's it, not to corrupt the file or change the data itself. This is the main intention. So the compression will not corrupt the file. This should be kept in mind. Next, how many or what is the ratio of compression? When you talk about the ratio, we have seen here the multimedia concepts, that image, video, data, text and program. To which of the multimedia element the data compression ratio is very high? This is the common question that would be asked by everyone, or everyone wish to know that. There are certain data files such as text, pictures in a BMP format, and some text database files that can be compressed up to 90% or sometime even more. Means compression ratio is achieved for more than 90% and above, whereas the other data types such as the files with respect to image, videos and other things are comparatively very less. So we will see why in the further classes why compression ratio is very much high here with respect to multimedia elements such as text and other things, why not as much as 90 or and above with respect to other things in the further sessions. Next, few more things needs to be made very much clear. There are a lot of terminologies. Many of the people or students make themselves confused with respect to few terminologies. What are those? Those terminologies are data trimming, data deduplication, and data compression. So there is a very clear distinction between all the three techniques. So one should be very much clear in making the difference between the data trimming, data deduplication and data compression. Never come to a conclusion that stating that all the three are one. So let us look into the concept of data trimming. What is data trimming? Let us take an illustration. Now consider you have a video of 2 hours. Now consider this is a video stream. Video stream, it is for 2 hours. Now what do you mean by trimming? You know very well, chopping of particular portions is called trimming, or unwanted things, and excluding it and retaining the wanted portion of the area is said to be a trimming. Now what I do? I edit here at this point and again at this point. So what I do? I cut here and also cut here. Now I will exclude this and I retain this. Now what I have done? Consider this is a 2 hours video stream. Now I have edited and trimmed here. I have cut this portion and excluded, and even I have excluded this portion. Now I have retained this portion, which is a video of 1 hour. This is called trimming. Now I have removed unwanted things and I have retained what is needed from the main concept or a main data stream. This is called data trimming. Now what do you mean by that? Data deduplication. You should be very clear, I am using the word deduplication, not data duplication. The name itself suggests duplication means doing repeated things. Now I am doing deduplication, means a reverse. Now consider a cluster. This is the cluster 1 cluster. What we have here, consider we have a data set, letter A file. Let us consider it as a file A, and also here we have a file B, and we have file D, C and D. Okay, and also we have one more thing, we have file B here. file D, and now what happened? Again file A has been repeated, and now file C has been repeated again. Look at this now. This is a cluster of files where this cluster consists of different files like file A, B, C and D. And again what has happened? B. Look at this. This file has been duplicated again. Now D, again D file has been duplicated again. See A has been duplicated. Similarly, C is also duplicated. There might be n number of duplication as such. Just for the demonstration purpose, I have been using with the small cluster. What is this? It says data deduplicate, means remove the duplication. Now what is this? In the next cluster, now here it's a process. What is this process? This process is deduplication process. Now what I am doing? I am removing the duplication. So A, B, C, D is there. A, B, C, D. So again B, D, A, C is the same thing. So what I do? I don't duplicate those things. I retain with the same thing. Now if there is a consider the same thing, if here it is Z. There is one more file called Z. What I do? I write the file Z here. Simple. I am taking all the files with one representation. So no consecutive representation of ambiguity here. Now look at this. This is a cluster and this is also one more cluster, where here in the cluster, first cluster, you can see a lot of files been duplicated. In the process of deduplication, I am removing all the files that has been duplicated here, and this process is called deduplication. Whereas in a trimming, I am chopping the file. So whichever the portion I want, I am chopping those part and extracting those part of data that I wanted and retaining that. That is called data trimming. Whereas in a deduplication, there might be n number of files that might be represented in multiple terms or multiple times. Those things are removed. Now let us see with respect to the data compression. So let us consider a cluster again. I have a file A and I have a file B. I represent A again and D. Okay. Here look at this. We are not concentrating on any replications or duplication concept. Here we are talking about the compression. So next I have one more file B and I have a file called C. So this is a initial input cluster. So what I am doing, the next process that I am supposed to do here is the compression. This is said to be one more cluster. What does compression says? The compression definition says that like this: suppressing or reducing the size of the file is said to be a compression. Now let us consider in the cluster A, the size of file is said to be 8 bits. Okay. Now consider the size of file B, since it is a bit lengthier one, I will write it as 10 bits. And here I will write it as 8. And here I write it as 6, and this looks very much smaller size of file, so I write it as 5, and write it as 7. Now this cluster has 4, 5, 6 files, each of which with a different file size. So it might be similar or different. So we are not bothered about the type and the size. We are bothered mainly about the concept of compression. Look at this. This file is representation is with respect to 8 bits, means it is stored here using 8 bits of information, whereas this with the 10 bits here it's again 8, 6, 5 and 7. Now we are applying the concept of compression. What happens when we use the process of compression? The definition of the compression says reducing the files. What happens now? So how do we compress? What the kind of compression is done? We'll discuss later. So there are few methods, procedures and algorithms that are applied on those files in order to compress that. We'll look into it later. Now we use the process of compression. What happens here? The file 8 bits is been reduced to 6 bits. Here the file B using 10 might have been reduced to only 5 bits. Again A, which was using 8, might have reduced to only 3. Again D, which was using 6, might have reduced to 2 bits of information. Again here the file B, which was using around 5 bits, might have reduced to 4, and finally the C file that was using 7 might have reduced to 4 bits. So look at the difference here. Now what has happened? The size of file A, which was using 8 bits, after applying the process or undergoing the process of compression, it has reduced its size to 6 bits. So representation is small. It can happen. So you might ask here, sir, it was 8 bits and why only 6? Whereas here it was 10 bits, here we come across to 5 bits. So compression is more in some case, and some other compression is very less. Why is this? As I previously said, it depends on the multimedia element that is been involved in the file. For a text and a program, the compression rate is obviously very high, whereas with respect to video, images and other audio things, the compression rate is very less. We are not talking about what kind of information is stored, we are just talking about the file that has been represented. So these are the 3 elements, okay, we need to know. The first one is data trimming, where we trim or chop the unwanted things and retain the executed or wanted data that for the future execution, and those kind of concept is called data trimming. Whereas data duplication, we remove the unwanted things or repeated things, okay, we don't say it's unwanted things, we remove the duplicated files, so and retain a copy of every file one. So here in the data compression, we are not doing a data trimming or a data duplication. Here we are just concentration is spent on trimming, reducing the size of the data file. That is called the data compression. So a clear distinction is made between the 3 concepts, that is the data trimming, data deduplication and data compression. Next we will look into the one more beautiful concept with respect to diagram, which is called the block diagram of data compression. In many of the question papers, it's been asked, what do you mean by data compression? Explain the concept of data compression with help of a need diagram. In that case, you are supposed to explain the concept along with this diagram. Now look at this. This is called original data. We know that always the database is represented in a tumbler shape. Now the original data is encoded. That is, compression is done, and that process is called encoding. So, when original data is compressed or compression is happening, it is been represented in a different way. Means the data is first compressed. So, what happens here during the process of compression? We get a compressed data. Means with the process of compression, we call it as encoded or encoder. We compress the original data into a compressed data. So, if we want to regain the original data, what we do? The same is again decompression, and that process is called decoder or decoding. So, next is the encoding or encoded format. Here it is called decompression or decoding format. After doing a decoding, we will be able to get back the uncompressed or decompressed data. So, this is the block diagram for compression and decompression, whereas here the process of compression is happening, which is encoded into a compressed format, and here the data is called the compressed data. So, if you wanted to regain the original data, then again we need to decompress it, and that process is called decoding or decompression through decoder, and we retain or gain back the original data. That is called decompressed data. These are the things I had wished to discuss in this session. So, summarizing this, let us recall what we have discussed in this session. We have discussed what do you mean by compression itself. We have discussed what is the difference between the general compression and what do we mean by the data compression. We have seen why data compression is very important, and we have discussed about what is meant by data compression and how does it work. And we have also seen why data compression is very important concept or a topic in today's world. We have seen the need for the compression, and we have also seen the various types of compression methods, that is lossy and lossless compression. We have also seen or discussed a brief differentiation between the lossy and the lossless, and we have seen, will the compression corrupt the file? Yes or no, we have discussed it, and we have seen the different types of files that are associated with the compression, and mainly we are able to bifurcate the difference between data trimming, data deduplication and data compression, and finally we have discussed about the block diagram with respect to the data compression. Thank you very much.